In Geometry Section 8.1, we're dealing with the geometric mean. Now, a geometric mean basically means that you have two numbers, and in each two numbers, how you find the geometric mean is that this is the ratio, the bottom, the denominator in the first, is equal to the numerator on the second. So it's a proportion where the bottom denominator equals to the second proportion's numerator between these two numbers. And this is important when we're finding, when we're looking for proportions and we have x. Usually, if this is the missing and this is missing, then we can find both simply by cross multiplying, and we still have x squared. We'll have a times b equals x squared, and we'll square root both sides. But you'll see that in action a little bit more into the video. Theorem 8.1 then shows us that if I have a right triangle and I create this line, and if you remember from your vocabulary in the past, okay, that the line that goes from top straight down at a right angle is called an altitude. So if I draw a right triangle, any right triangle, and I create an altitude down, it creates three similar triangles. And the first triangle is XYZ, which is the biggest one, okay, the original right triangle. And then you have this small one right here, YWZ, okay, this one. And then you have this one also. So it converts into the bigger one, then the middle one, and then the smallest one. And they're all similar to each other. So X is similar to X is similar to Y. They're all equal. These angles are all equal to each other. All the right angles are equal to each other, and all then the third angle is equal to each other, so it makes all the sides proportionate. So when we have similar triangles, then we have a whole bunch of proportions that we're dealing with. So 8.2 and 8.3 basically tells us that when we have this situation happening, some of the lines, because they overlap, become geometric means. So if I have, for example, YW, if I look at the line YW right here, well, this is proportionate to XW over YW, so this over this is proportionate to this over ZW, okay? So you have a geometric mean basically here and here. So that means usually in a regular similar, when you're dealing with similar triangles and you're creating proportions, you have to make sure that you only have one missing variable. If you have more than one missing variable, then you can no longer solve. But with the geometric mean, it makes two of your missing variables the same so that you're able to solve with less information. So 8.3 tells us that XY is the geometric mean between XZ and XW. And then YZ is the geometric mean between XW and WZ. So these are important ones that you're going to put into your flippers. And the easiest way to solve a triangle according to these methods is that when you have a right triangle with an altitude, for me, I just replace the letters, okay, with these letters here so that all of this falls in place. It's hard to find which one matches up with which. I just switch all the letters out, and I'll show you what I mean in our example problem. So go ahead and pause and write this down, and then do your vocabulary, and we're going to go into the next one. Our example, our one and only example. Okay, so in this case right here, we have triangle JKL and M. So they want us to find C and D. So what I do here is I'm going to replace this. Now look back in your notes. I'm going to replace this with the letters that I have in my Theorem 8.1, the notes. So L would be X, okay? And then you would have W, right here, M would be W, and then J would be Z, okay, and K would be Y. Right? So I'm going to tell the information that I do know. I do know what K, I'm going to use the letters from the video, from the prior notes. I know what YW is. YW is 10. Okay, this is what I know. Okay. And then it tells us that JM, which is ZW, equals 5. What I want to know is C, which is WX, which is C, and then WX, which is C, and then D, which is KJ. So, or ZY, YZ. Okay, so this is what I want to know, and this is what I do know. And how I do this, the reason why I do convert into these letters is now I can go back to this. Yes? And when I go back to this, I can then look here. I need to, again, I can solve the proportion as long as I only have one missing variable. But if I have more than one, I can't solve it. So I'm going to look here, and I'm going to look at the two informations I do know. YW and ZW, and I want to look back. Which one of these has both YW and ZW? Well, if I have theorem 8.2, okay, theorem 8.2 tells us that XW over YW equals YW over ZW. So first I'm going to, okay, I figured out what I know, okay, the ones I do know, the ones I want to know, and then I have to see with the ones I know, what equation can I fill in where only one variable would be missing? Because if I have more, again, I won't be able to solve it. So let's just fill it in just to check. XW is the same thing as WX, right? Which is C. Okay. YW is 10 equals another YW, which is 10 over ZW, which is 5. So I have how many missing? Just one variable missing. And you see how the geometric mean comes in handy, because if this was another proportion and I only have two, I would not be able to solve any of them. So it comes in handy. Now we can cross multiply. So we end up with 10 times 10, right? And then 10 times 10 equals 5 times C, which is 100 equals 5C. Divide by 5 on both sides, and I get 20 equals C. There it is. Okay, so that's C. But I'm not quite done yet, because I still need to find D. And I don't think I left myself enough room. So let's delete 8.2 here. And solve it here. Okay, so now I can add something that I do know. I already got what I want, check, and I can put it back into what I know, which is WX equals 20. Okay, now with these three, and any combination, I don't have to use them, I need to figure out if I can solve YZ. Now, instead of seeing which ones I can figure out, I can now, and I have more than enough information, I can now look for exactly what I'm missing. Well, in this case, I'm missing YZ. So I can only use equations with YZ, or else I'm not going to be able to solve what I want. So let's look at here and see which one has YZ. Well, this doesn't have any YZ, but this has YZ. So the second equation in 8.3 states, and maybe so you guys can see, states XZ over YZ equals YZ over WZ. Okay? And again, I chose this because it is the only equation I have out of the three that we were given that I can find YZ. So I know what XZ is, right? XZ is this right here. So I don't necessarily know what that is yet, but I know that C equals 20, so the whole thing added up together is 25. So XZ is 25 over YZ, which is D, equals D over WZ, which is 5. Okay, so we do 125 sorry. Okay, So we have 125 times 5 is 125 equals d squared. So now we're going to square root 125. Okay, square root, because d squared, the opposite, is 25. Yeah, square root 125. Square root both sides, and we get 11.18 equals d. Okay? So again, I cross multiplied. I ended up with 125 equals d squared, because there's two d's. D times d, it's not 2d. D plus d is 2d, but d times d is d squared. So I did d squared on this side, and I square rooted both sides, and I ended up with d equals 11.18. So again, it's a matter of what you know, what you want to know, and then figuring out the right equation to fill in so that you only have how many variables? A maximum of 1. So go ahead and turn your books and do page 4, do 2 and 6 on page 435, and I will see you in class.